Hi, this is Dhruv Leela and this is my submission for the CML102 assignment 1. And as we know, there are like three parts of this assignment. In part A, we were supposed to identify the point group of the crystal which was given to us. In part B, we were supposed to edit the BATIO3 CIF file and produce different crystals. And in part C, we were supposed to have a discussion on X-rays and different aspects of it. So let's just get started with part A, point groups. So let's first see like what point groups do we have. So as we know, we have like 7 crystal systems: cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic, triclinic, and so on. And we like classify them on the basis of cell constants, angles, and symmetry elements. Now, the reason why it is included in my presentation in the first place is because I plan to use this property of crystal system to narrow down different point groups. What I mean by that is, as we can see in tetragonal, all point groups have fourfold symmetry. So if I can identify that the crystal doesn't have fourfold symmetry, I can like straight up eliminate all these tetragonal point groups. Same goes with sixfold symmetry and so on. So it is a very useful strategy. And by the way, I'm -4, -3, -2, and so on. Like these just mean 4 bar, 3 bar, 2 bar, like the inversion axis. So let's just to avoid any confusion. So let's see. Let's eliminate some crystal structures. So from the crystal, it was, so to describe the shape of the crystal, it was sort of if we see the top view in the second picture, it was sort of hexagon, like it was, but it was not a regular hexagon. The side lengths were pretty different, and and again, this doesn't mean it is like an hexagonal crystal structure. I'm just like giving an extremely like a rough idea like what it looked like. So it sort of looked hexagonal, and if you see here, it's pretty clear that this crystal does not have a fourfold symmetry, because the way it is shaped, and it also doesn't have threefold or sixfold symmetry, because like I said, it is not a hexagon. It is not a regular hexagon. Like if you look at the top, so if you rotate by 60 degrees or 120 degrees, like it will not superimpose with the crystal again. Basically from the image it was pretty clear. So using this observation, we can eliminate cubic, trigonal, tetragonal, or hexagonal crystal systems. We can like eliminate all 4 of these crystal systems. So as we can see, so tetragonal is gone, hexagonal is gone, and trigonal is gone, and cubic, like all of them have 3 or 4-fold symmetry, so it is also out. So as we can see, it is a like very powerful observation, and like from 32 point groups, we are like down to 8 point groups from orthorhombic, monoclinic, and triclinic. So like I said, so how do we proceed further? So if we see now, there is a mirror plane in the crystal. As we can see, like I have shown, so like this line sort of indicates that there is a mirror plane like cutting it, and then you have the face here. As you can see, the top view, like basically it is like parallel to the plane shown in the second image, and like perpendicular to this, it is like going into the screen. And here also it will be there will be a mirror plane. So because we have a mirror plane, we can like eliminate again some point groups from the 8 point groups we had. So that means the 2 point group is gone, 2 is gone, 1 is gone, and 1 bar is gone. So we are left with 4 now: MM2, 2 by M. Now to further classify them, we can see if there are any more mirror planes in the crystal. If there are any more mirror groups in the crystal, we can eliminate MMM. If there are more, then we can eliminate MMM and MM2. If they are not, we can eliminate 2 by and M. So let's see. So if we look the crystal closely, there is no other mirror plane in the crystal. So as we can see, I've drawn lines here, like the planes are cutting the screen like along these lines, if it makes sense. So we don't have a mirror plane here because, like I said, the side lengths here are different and so on. So again, it will, if we like take the mirror image, it will not superimpose with the mirror. So since there is no other mirror plane in the crystal, we can eliminate MMM and MM2 as well. So we are down to like the final 2 point groups, 2y and M. Now the difference between them is purely that if we have a two-fold axis along this line, but from the sample given to us, it was like, it looked as if there is no two-fold symmetry, because if we like I have like tried to like do a 180-degree rotation on the image and try to show it. I'm not sure if it's like exactly visible, but like suppose this length is much shorter than this length, and so on. Like this is much bigger here, and you have a longer here but shorter length here. So essentially the it looked as if there is no two-fold symmetry as well in the crystal. So or particular the mirror plane. So that again like eliminates the 2 by M point group. So it is like safe to conclude that the point group of our crystal is M. So that puts that into the part A.